everybody, and welcome to the Lesson 5.1, Relations and Functions Notes. Today we're going to be talking all about functions, which are inputs and outputs. To start us off, I have a DVD vending machine. Question 1 says, what DVD would you receive if you inserted your money and pressed the following buttons? So if we were going to press A1, we would have to look at row A and under column 1 to see what movie we'd get out. And as you can see in the top left corner, we would get The Hunger Sports. If we were to press C2, we would look at the C row under column 2, and we would get the movie The Light Knight. And lastly, if we were to press B3, we would look at row B under column 3, and we would get The Amazing Insect Man. Question 2 says, assuming the machine were filled properly, describe what would happen if you pressed the same button twice. So we said if we pressed the button B3, we would get The Amazing Insect Man. Now imagine if we pressed B3 again. If it were filled properly, we would expect to get The Amazing Insect Man again. So if this machine were filled properly and we pressed the button twice, you would get the same DVD twice. So this vending machine is an excellent example of a relation. Our input is pressing the button, and by pressing the button, it causes us to get a DVD output. Now, each combination of input and output can be expressed as a mapping. And I have it represented here. The input goes first, followed by an arrow leading to its corresponding output. For example, we said up here that if you pressed A1, we would get the movie The Hunger Sports. So A1 is my input, and it leads to The Hunger Sports. Now we can do this for every single combination of buttons to movies. What I would like you to do is pause the video and try to represent each input and output pair with a mapping. So we just did A1 together. Try doing A2 and its corresponding output, and then A3 and its corresponding output, and so on until you represent all the buttons on the vending machine. So pause the video and give that a try. Welcome back. Hopefully you were able to write all of the following mapping diagrams. I stopped at B3, but I think you get the idea. A2's output is The Revengers, A3's output is Battle Sales, and if you notice I skipped B1, and it's because B1 is sold out. If I were to press that button, I would get no DVD, nothing would come out. So I can't write a mapping if there's no output, so I just skipped B1. Now a mapping diagram is only one way to represent a relation. Another way to represent a relation is with ordered pairs. We've seen ordered pairs before because that's what a point looks like on a graph. We use parentheses, input, comma, output, or as you've mostly seen, X and Y. So for this first one, if my input is 1 and my output is -2, my ordered pair would be 1, -2. Make sure you have those parentheses and comma. That is important for the ordered pair. The next ordered pair would be 2, 1. Then we would have 3, 4, and 4, 7. Now that we've seen different ways a relation can be represented, I want to now talk about the difference between a relation and a function. A relation is information that can be represented by a set of ordered pairs. And ordered pairs are just a series of inputs and outputs. So for example, if I took all of these ordered pairs right here, and I wrote them in set notation is using curly brackets, and I listed out all of my ordered pairs. This is an example of a relation. I have a series of inputs and outputs written in set notation. Now a function is a special type of relation. A function is a special relation in which every input is paired with exactly one output. So if I had the following mapping diagram with inputs 1, 2, and 3, every input can only have one arrow coming out of it, meaning every input only has one output. Now let's take a look at this mapping diagram right here. I have two inputs, but only one output. I want to know, is this a function or not? Well, my rules for a function are that every input can only have one output, meaning every input can only have one arrow coming out of it. And that's true. 1 only has one arrow, and 2 only has one arrow. It's okay that 2 inputs have the same output, as long as they only have one output. So if you ever see a mapping diagram where one input has 2 arrows, 2 outputs, this is not a function. For a relation to be a function, every input can only have exactly one output. So in question 5, it's asking, does the DVD vending machine example represent a function? So let's look back at our vending machine. Does every input only have one output? Meaning, does every button have its own movie? And the answer is yes. There is never a time where you will press a button and you will get 2 different movies. Now, it's okay that 2 buttons have the same movie. For example, if you press C2 or C3, you will still get the Light Night. This is just like what we said in this example right here. 2 inputs can have the same output as long as they each only have one. So yes, the DVD vending machine is a function because each button, which is my inputs, has exactly one output. And our last question, imagine a machine where you input an age and the machine outputs the name of anyone who is that age. Would this machine represent a function? Explain why or why not. So for my input circle, I have an age, and my output circle is the name of anyone with that age. Well, let's take the age 15 for example. I have a friend named Jack who's 15, and a friend named Sally who's 15, and a friend named Rachel who's 15. And I think we can see that this is not going to be a function because the input 15 already has 3 outputs, and it probably has many, many more because I think a lot of you are 15. So no, this is not a function. Some inputs will have multiple outputs. And for a relation to be a function, every input can only have one output. And that is our introduction to relations and functions. If you have any questions, please let me know, and I will see you in class.